Okay, hey Javon and Nikki. So just like we were talking about in office hours with this problem, we know that equilibrium is going to favor the side that is opposite of the stronger acid. So I'm going to write that out here, that we're going to favor the side opposite of the stronger acid. So what we have to do here is identify which acid is the stronger acid. So let's first look at B, because this one's a little bit conceptually easier to understand. And we can identify our acid as either being the CH4 or this terminal alkyne, because if we see through the reaction, we know that this organometallic is going to be the base because it has that negatively charged carbon. If the organometallic is the base, then the other species has to be the acid. Going over to our products, we see that this carbon right here of the lithium methyl species is going to have a negative charge, so that will be the base, and thus this guy has to be the acid. So comparing the acidic quality of our CH4 group methane versus our terminal alkyne, whoops, I forgot a carbon there. We know that when we're evaluating acidity, one of the trends that we can think of is the orbital effect. So this is way, way, way back for exam 1 material when we're ranking acidity. And the orbital effect says that sp2 hybridized carbons are most acidic, or sp are most acidic, than sp2, then sp3. So this is being ranked from most acidic to least acidic. So this tells us that our better acid in this case is going to be this terminal alkyne. And remember that I said that equilibrium is going to favor the side opposite of the strongest acid. So equilibrium will favor the left for B. So we know that B is definitely going to be wrong. Okay, but then let's talk about A. Let's figure out why A is right. So if we go back and we think about all of the different rules that we had when evaluating acidity, we had a couple things we could think about. We could think about atoms in the same row, atoms in the same column. We could think about resonance, and we could also think about the inductive effect. So let's first, before we get into any of that, let's just identify. We know that lithium aluminum hydride is going to be our base, which means that this guy has to be our acid. Looking at our products, we know that we're going to have an O- charge here and a lithium plus charge. So that as a result is going to be our base. And then when we're thinking about our acid could actually be that H2 or that AlH3. So we have to kind of think about both of them. Right off the bat, though, we know that H2 isn't going to be our acid. H2 is just typically not an acid. You have to do something super, super crazy to create that a hydride from H2. So we just know that H2 isn't typically an acid. With AlH3, that is going to be more of an acid than H2, but it's still a pretty horrible acid. And the reason why I was a little hesitant on this problem is that I didn't have an overall rule. Like of those 4 rules, I couldn't point to one of them and be like, yes, this is exactly why. But I think that how you could go about doing this problem is, number 1, you know that you're comparing oxygen versus aluminum. And if you think just like back to all of your chemistry experience, oxygen has definitely been an acid before, but aluminum is just never an acid. So that's one thing we can think about. The other thing that we can think about is if we kind of evaluate it in terms of electronegativity. And I know that this isn't 100% following the same rule from exam 1 because they're not in the same exact row. But we know that oxygen is more electronegative than aluminum. So as a result, oxygen is going to be better able to stabilize those electrons than aluminum. So just thinking about both of those ideas, the fact that we know that oxygen can be acidic, but aluminum we've never talked about being acidic. And then secondly, just the fact that oxygen is more electronegative than aluminum. That kind of allows you to kind of reason through this or deduce exactly what is happening. So I hope that this helps, and I hope that you guys have a good night and that studying continues to go well for both of you.